It's okay.
Okay. I'm Paul Camacho, and I'd like to take a few minutes to share some insights on random numbers. There's been a lot of discussions on random numbers over the past few days, and I'd like to use the theme of Noneuclidea and show how that can lead to random numbers and how to use that in software then later on. What I'm going to show you at first are some pictures of an artist. His name is Mo Edoga, and he, I guess he's what you would call the father of non-Euclidean art. What he does is he takes pieces of driftwood and straps these together using pallet strapping to build different shapes, objects, and this one that you're going to see is started out with a metal frame that he's standing on, and you can see him starting to assemble some driftwood on this platform. And a little bit in the background here, you see this pile of wood that's laying there, okay? That's all going onto this structure sooner or later. Now, let's have a look at this. As it goes on, it keeps getting bigger and bigger and bigger and bigger. And what this is it's a way of assembling objects, looking at it from programmer's term, a way of assembling objects, and the order in which these objects are assembled is much more critical than the objects themselves. Okay, let me get one or two more. Here you can see a little bit of detail of how this is done. This is done by drilling into the wood and then using this pallet strap to tie these pieces together. When these pieces are tied together, you basically, it's pretty much indestructible. So when you think about this, starting with just one piece on a platform and tying all of these pieces together, there's a certain decision-making process that goes on. I think that's pretty easy to visualize. You have to go to the pile, get a piece that seems to fit somehow, place it in there, and then fasten it. And when you're finished, that whole chain of events from the starting point to the end, that's what determines your result. That's the deterministic part of that. And when you think about that for a minute, isn't that what we're trying to do when we're using random numbers? We're trying to get pieces, put them together, and we always get stymied in the computer part because the numbers aren't really random. They're distributed evenly, and if you were to just pick out any piece from the pile and start tying it together, it probably wouldn't work. So there has to be some mechanism, and this mechanism of decision making is what we try to do when we build software. So having said that, let me close this and let's have a look at some software that I built based on that principle. Okay, what you're going to see here is a method of playing roulette. This is a machine basically that's constructed from components pretty much similar, like taking pieces of wood out of the pile and strapping them together. Because in the end, in this program, and I'll let it run for you in a second, this program has no central core that controls the outputs or the inputs. Each piece that you see, each switch, each lamp, each display is all encapsulated, and it's just connected together by means of their properties and their methods and events. So the idea behind this little machine is it possible to win at roulette, yes or no? We have a lot of, when you look at random numbers and statistics, you basically say, no, it's not possible because of the 0 and the 37. Let's have a look what happens if we take some real numbers that were actually thrown in a real casino. And what we see here are the numbers on the left-hand side of this column, and on the right-hand side, we see how many times they occurred. So theoretically, if you picked the 9, we have 38 rolls. The 9 came 3 times. If you started at the first roll and just played the 9, theoretically you couldn't lose, right? Of course, you don't know this in advance, but I'll show you how you can. The idea behind this is also not trying to predict which number comes. It's the same thing. The order that the numbers come is what's important. So we have some betting strategies on the bottom here. You can see the little buttons there where you can choose a strategy. And what I'm going to do is, the lamp that's on is the strategy. You can combine some of them. We're going to throw these rolls one after the other and observe the order that they come in. And we can do this once, 100 times, or 1,000 times. So let's say we pick a strategy that says the number that occurs the most is the one that we'll bet on. Afterwards, after the 38 rolls, we know the 26, oops, sorry, let me get that tooltip out. The 26 is going to come 4 times, but we don't know that in advance. We don't know that. So let me just let this run through. Okay, you can see at the top, it's calculating place 1 and place 2 in order of the appearance. So after 38 rolls, you would have won 43 things theoretically. Okay, I want to go back before I continue and show you up here what we have. We have a left, a right, and a both, because the rules of roulette say that the first time you have to spin the wheel this way and throw the ball that way, and the next turn you have to do it exactly the opposite way around. So it's always, the pot is always alternating from left to right, from left to right. And so I want to see the original. This is what this little checkbox here does, is it's not going to roll these in a random order, it's going to roll these in the original order that they came. So we can compare. So all the numbers come, and in the original order, if we had have known this in advance, of course, we probably would have won a lot more. But since we don't know that in advance, and all we did is you calculate which number comes the most often, and you put that chip on that number, and you're going to lose a whole lot of times, but statistically you're going to win more than you lose. So there's some, there's a catch to it. There's a catch to it because, let me do this one more time. You'll notice the red is the number that comes up, and the blue are the bets that are being placed. And it doesn't start betting until the first number comes up twice. That's very important. Because when you lose a lot of money playing roulette, what's happening is it's not the 37 thing. It's you're trying to predict a number that never comes. In 36 spins, you'll have about 1/3 of the number that never show up, 1/3 of the numbers that show up exactly once, and the rest of them, they show up more than once. So that's actually the statistical thing. So people try to predict and try to predict and try to predict on numbers. Oh, I know the 18's got to come. Oh, I know the 22's got to come. If it's never shown up, then the chance of it actually showing up are 50-50. That's what your true chances are. So let me just get back to the left and right thing. Let's have a look at only the left-hand spins. And actually somebody went into a casino and got these numbers. And there is okay, this is only the left-hand one, so there's not 38 anymore, there's only 19 spins. And this is also in the original order. You can see that the 26s here are not only coming on the left hand, because this is where the human factor comes in. You have somebody that's spinning the wheel that does this night for night for night for night for weeks and weeks and weeks and months and months and months. So you do have a certain routine, and you do have a certain factor that's not really truly random in the roulette game. It's the human. It's the human that's just accustomed to spinning, and it's on this table, and he's doing that. So what the guy is trying to do, that collects the numbers, he's trying to figure out if he can spot somebody that's consistently throwing the same pattern with the left hand and the right hand, and then you would, of course, only place bets when on every other spin. You wouldn't place a bet on every spin. Let's try this one more time. This is the other hand, and you can see that the 9 that came up 3 times always was spun with the right hand. So if you're going to spin the 9, you can save yourself a lot of money by only betting on the 9 when it goes on the right hand. So actually what this program does is it'll let you input a number, it'll let you input a permanence, which is a sequence of numbers, and it will let you play against that using a predefined strategy 1,000 times, but not necessarily in the original order, of course. The numbers are not going to come up the next day, and the order is not going to be the same the next day. You have to be able to identify and do what that program is doing up in the analysis. If you can do that in your head, as the wheel's turning, you're going to win. You're probably going to win. Your chances are high. The thing is, when you get into a lot of numbers and you have a lot of place 2, let's have a look at this. Watch how place 2 starts changing. You're only betting one. Or let me get something that's got more numbers. Okay, if you watch this for a moment, you'll see you're only betting 1, 2, or 3, but as time goes on and the statistics of the numbers have changed, you're going to have to start betting 10, 20 numbers for this to work. So there is a catch to it, because you have to be able to calculate this in your head. You can't take any computers with you or anything like that. You have to be able to take it and figure this out in your head. But when the computer does it, in most cases where we have real numbers, you actually win. If you take randomly generated numbers from a computer, then you come out 0, 0, or you lose. Because there's just a certain tick more that the human being puts into those numbers as he spins the wheel, and that the computer can't simulate at that point. So to get around, to make a long story short, to get around the random number issue, what we did is we took real numbers and sorted them like a deck of cards. If you take a stack, let me stop this here and get back into here. You see that we have these numbers sorted by the order of not by the order of appearance, but by the numbers of their appearance. If you start just picking out one of these numbers, and this was the problem that we had with this program to get it to work, if you just start picking out a number from this pile and say, okay, let me just take one of those numbers, your random number generator is you're going to have to get a number between something and something. Let's say if you have all of the numbers covered, you're going to take a number between 0 and 37 and pick one of those out, and then if you pick out the 26, then you would roll the 26, and then you have only 3 left instead of 4 left. Okay, can you follow me? You're taking the number out, rolling it, giving it to the user on the screen, and then decreasing it. So.
Well, you've got about 2 minutes total left.
Okay, I'm almost done. Okay, I'm almost finished. So the problem with the random number generator is that when you start picking these numbers out, at one point you get to a point where you pick a number, let's say that 24, but that number isn't in your permanence anymore, so you have to spin your random number generator again. And what happens is, we tried that approach, and the numbers that came up the most often, they started showing up at the end of all the sequences. So you would lose, 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 and towards the end of the game you would just win really big because you were constantly betting on the winning numbers. So to get around that problem was actually very easy. We took all the numbers and made a deck of cards out of it. We have a deck that has 4 26s, 3 9s, and then shuffled that deck and then always take off from the top. That's quite different from just picking one out of the pile and then trying to resize the pile to get the number. Okay, that was it.
47 seconds to go.
Do you think the casinos are thinking about this?
Um,
Right-hand thing?
I think, yeah, because they publish these numbers also, and you can go to a lot of casino websites, and they publish the numbers, but they don't publish which way they started,
I see.
and they don't publish, you can see when, what they call when the hand changes, is that you'll have little dash marks, and then the next guy will be up, but you don't know which guy,
Where you started.
you don't know which way he started, and you don't know which guy it is, so you can't go in there and say, okay, this guy is throwing a lot of sixes, because by the time you get there, he'll be at a different table, or he's on his coffee break, or
Have you
whatever.
ever talked to someone who spins the wheel?
Yeah,
Whether they purposely try to
yeah,
change
they
their
do,
muscular
they do. No, they don't purposely try, but it's the haptic nerves of the hand, you don't have much choice. You know, if you snap your fingers, after your haptic nerves adapt to that, and it just takes less neural impulses, and when you get routined in something, then that routine starts to show up in the permanence. And so that's what we're trying to do, is attack that with this system.
Thanks, Paul.
Is that
Okay.
your limousine outside?
That's my driver's limousine, my helicopter.